All right, this video is a continuation of our evolution videos, and this one is presenting evidence that is used to support that theory of evolution, specifically using the fossil record and a field of study we like to call biogeography. Now, helping me today is, I'm sad to say, my arch nemesis, Mr. Hillis.
I'm getting paid.
That's not true, but you might be thinking to yourself, why would you include Mr. Hillis in this? You hate each other. We have mutual respect for each other, like Professor Xavier and Magneto. So we decided to occasionally get together and work together. So anyway, there we go. Let's get started. So to sort of preview everything going on here, I'm actually going to tell you a few of Darwin's observations from Origin of Species. Remember, Charles Darwin was the guy that developed the theory of natural selection, influential in building evolutionary theory. But anyway, a few things you notice. First of all, around the world, there are species that are different species that look incredibly similar. Furthermore, and kind of separately, I guess, within very close areas, depending on the terrain, you can see that there are different species in different areas that are still pretty close by to each other. And finally, and Darwin actually, this was back when we were first starting to actually look at fossils, Darwin caught on to the whole fossil thing and noticed that, life on Earth hasn't always been the same. In fact, there were species that were on Earth at that time that really weren't in the fossil record. And likewise, there are things in the fossil record that were not on Earth at that time.
And this was controversial at the time, making these claims.
Yes, absolutely controversial because it was thought that all life on Earth had always been the same. There's the bell. There we go. But it was thought that all life on Earth had always been the same, no matter what. They didn't really even know what dinosaurs were at that point. So, but anyway, we're going to address all these ideas in this little presentation here. But hopefully you guys know what fossils are. Mr. Hillis knows what fossils are.
I've always wanted to be fossilized.
Yes.
It's a way to go.
And we'll talk about how that happens in a minute. But fossils are preserved remains of organisms. And the reason why they're important for evolutionary theory is that scientists take a look at them and they use them to speculate where species on Earth now or even previously might have evolved from. And they use particular fossils called intermediate forms quite often. And intermediate forms are fossils that represent maybe a midpoint between two species that we know exist, one in the past and one further along in time, whether it be a current species or even, maybe two dinosaurs that existed in separate time, and they find a fossil that looks like it might be the midpoint between those two. Really famous one up there at the top is called the Archaeopteryx. It's maybe the most famous intermediate form of all time. It is a dinosaur that also had feathers, but there's really we don't think it really could fly. But it's thought to be the intermediate form between dinosaurs and birds.
So that means not all the dinosaurs might have died off, and some of them could be present-day birds?
There are some that argue that birds have a closer relation to dinosaurs than our current reptiles have to dinosaurs. We're going to explore that actually in our next unit in a bit more detail. Hey, maybe this unit. We'll see. It'll probably come up in conversation knowing my students, especially now that you've said that. But yeah, we'll take a look at the heart and everything like that. But anyway, now there's some misconceptions about fossils that I need to set straight. First of all, fossils don't just form all the time. Fossils need specific conditions in order to form. So let's say we wanted to fossilize Mr. Hillis here. Well, you can't just let him lay out in the desert and hope he fossilizes, okay? You need to get buried alive, basically, or buried almost immediately after dying. And I'm not talking about in a coffin. I'm talking about in a bunch of sediment. So whether it be a mudslide comes through or a bunch of pebbles, or pebbles might even be too big, like sand. It
really has to be like mud and really fine silt.
Yeah, basically.
And liquid.
Really specific sediment to do that. And it could also happen in ice, but it needs to happen very fast, really. So right there, that sort of eliminates a lot of things from being fossilized. It's really rare that things get fossilized.
So if you take me to a muddy area, I should be nervous?
No. But anyway, so also certain organisms fossilize better than others, not to mention certain body parts fossilize better than others. So when we do make our Hillis fossil, his skin and, that that won't fossilize as well as, say, your bones.
Mm-hmm.
Okay, this is starting to sound really creepy, but this is why things with shells tend to fossilize really well, or with dinosaurs, we only really see their bones and we don't see any of their scales or anything like that. And furthermore, you might not realize this, but we rarely find complete fossils. Even Sue, which is maybe the most famous T-Rex fossil, which you're very lucky to have only just down the road in the Field Museum in Chicago.
An exciting place to spend the weekend.
Yes, free for teachers, by the way. But it was only discovered 85 to 90% complete, and it is the most complete T-Rex. I don't know about the most complete dinosaur, but most complete T-Rex. It's much more complete than most of the other fossils we have. Now, you might ask yourself, okay, well, if we never have a complete fossil, how do we know what they looked like? Well, you can compare other fossils, see if you can, like, let's say part of Sue's tail's missing. Maybe that part of the tail's there in another T-Rex fossil. There are also people who are just very good at, they're major experts at this stuff that, like, they know dimensions of bones, like, inside and out. And
I do not.
Yeah, that's not our area of expertise, but
we have an area of expertise.
That's true. But anyway, now some say there are gaps in the fossil record, but maybe when there's an understanding of these 3 points, it kind of explains why there's a gap in the fossil record. So anyway, now another thing about fossils that doesn't have to do with how they're formed, but fossils, they get buried over time. You can probably accept that older fossils are going to be deeper down in the rock because more rock gets piled on over time. Okay? Well, when we dig up fossils, things that are thought to have evolved later, such as vertebrates, they're found way up at the top, as opposed to things that very ancient, evolved long, long ago. So like way, way down in the rock layer, we only see algae and bacteria, and we see nothing else. We don't see any mammals. We don't see even any like fish or worms. I don't know. Worms probably don't fossilize very well anyway. But you only see stuff that evolved a long, long, long time ago. And even to a point where you get deep enough down, you don't see any fossils. Here's a larger picture of what that looks like, just so you can take a look at where we generally find things in the rock layers. So as you can see, we find reptiles more recent than, say, mammals.
Yes.
And here's some transitional forms between a what's thought to be the terrestrial ancestor of whales. Whales are mammals. We're going to get into this one in detail in class, but I wanted to show another transitional fossil example.